In this lesson, are going to be looking at logarithmic functions. So logarithmics come in handy. In the last lesson, we learned how to solve things that have variables in the exponent by getting them into the same base. But if you have an equation that is like this one, 10 equals 2 to the x, you can't get 10 and 2 as powers of the same number. That is not going to work. So you have to have a different strategy. One strategy would be to use your graphing calculator and graph it and try to use your trace key and solve and do some of those kinds of things. I'll show you one way to kind of get an estimate, okay? So we are going to go to our function key here, and I'm going to clear this equation out, and I want to graph 2 to the x power, okay? And I'm going to hit graph, okay? And so now what I'm going to do is I'm going to hit my trace key here. Sorry, I didn't want to go second trace. I wanted to go just trace. And I am going to go, I'm looking for how far I have to go up to get my y value to be 10. Because I remember I'm wanting to figure out where 2 to the x equals 10. So I'm going to scroll, and I know that it's, 3.1 is at 9.13, 3.4 is at 10.58. So I know it's somewhere between 3.1 and 3.4. I'm not getting a very good estimate right here. I could go to my table and keep changing the settings, but you're really not going to get very accurate information if this is how you're going to choose to solve it. So I cannot get these two as powers of the same number. I go to my calculator, I hit trace. Way too much of an estimate. So the next tool that you have to go through to then is to be able to use logarithms. All right. I think you have seen logarithms before, or maybe you have not. I guess I'm not even really sure. But logarithmic functions are sort of the inverse, the opposites of exponential functions. Okay? A logarithm, is the exponent y that makes b to the y equals x be a true statement. So this is what it looks like in exponential form. So you have a number to the y power. And let's say if you had 2 to the third power. So if your equation is 2 to the third, well, we know that 2 to the third equals 8, right? And so if I were to write this in exponential form, or sorry, this is exponential form. If I were to write this in logarithmic form, you can see that your b is 2, that your y is 3, and that your x is 8. So when I write it in logarithmic form, I would write it like this. Log of my b is 2, my base is 2, my x is 8, and my y in this case is 3. And that's how we would write that in logarithmic form. Okay? All right, so again, logarithms are the opposites of exponentials, just as subtraction is the opposite of addition, and division is the opposite of multiplications. Logs undo exponentials. It's kind of like squaring something and then taking the square root. They undo each other. Logs and exponentials undo each other, okay? You're going to use this basic formula right here. Log, base, answer, exponent. So you can go like this. Base, exponent, answer. Okay? And you can flip back and forth between these two forms right here, and you will be doing that a lot. Base, exponent, answer is the same as log base of your answer equaling your exponent. All right. And so we've got this going on here. We've got a little log with that in there. We will add to this log sheet as we go. All right, so in this case, I have two things written already in logarithmic form, and I want you to write them in exponential form, okay? So base is pretty easy to get. There's your base. So this is going to go to 2. Your exponent comes from what's over here. So 2 to the negative 4 equals your answer, which comes right here. And that is a true statement. 2 to the negative 4 does equal 1/16 because the negative exponent needs to go to the denominator and become 1 over 2 to the 4th, which is 1 over 16. Okay, again, base, exponent, answer. Okay, and we all know that 50 halves is 25, but just to kind of trick you a little bit. All right, now I have them in exponential form, and I want you to switch them to logarithmic form, okay? So again, you'll always go log of your base, and here's your base in this case, which is 10. And then your answer will be 1,000 equals your exponent, which is 3. Okay? And on this one, again, log of your base, which is 9, your answer, which is 3, and your exponent, which is 1/2. All right, so now we have this that you kind of might want to add to your little log sheet there. So you can do this, that's fine. Put an example on there. All right, then we are going to do these where we are going to solve logarithmic equations kind of using that property that we know. Okay, so first of all, this, yeah, okay. On your calculator, some of you are going to be tempted to press the log key on your calculator. The log key on your calculator is not going to help you in this case because your log key is only for things that are in base 10, and this has a base of 2. So that is not going to help you so much, okay? So, but the question is, log base 2 of 64 is what? That's what I want to solve for, okay? So I'm going to put a little x there, and then I'm going to switch this to exponential form, okay? So I will go like this. My base is 2, my exponent is x, and I get 64. Okay. Now, luckily, I can write 2 and 64 as powers of the same number. So 64 is 2 to the 6th power. And if you don't know that, you're going to just kind of have to play. Okay, I know you know that 2 to the third is 8, and then times 2, 2 to the 4th is 16 times 2. Just keep playing until you come up with 64. So 2 to the 6th is 64. Now that I have those as the same base, I can put my exponents equal to each other. So I just simply have x equals 6. Okay, so log base, I can also write this then. Log base 2 of 64 is 6. I could write it like that. All right, here's another one. Again, I don't know what this is, but I can switch this. I'm going to figure that out, and I'm going to switch this to exponential form, okay? So I will have 16 to my exponent, which is x, equals my answer, which is 2. And again, I can rewrite those as powers of 2. 16 is 2 to the 4th power times x. And then what's up above here, some people get tricked by this, but it's very simple. What's up above here is a 1 that's not written. And so then you can, since you have these as the same base, you can set your exponents equal to each other, divide by 4, and x is 1/4. Okay? And next, again, I don't know what this is, so 2 to the x. So again, base, exponent, answer. Okay? And so what you need to do is you need to rewrite 32 as a power of 2. 32 is 1 over 2 to the 5th. So as a power of 2, this becomes 2 to the negative 5th. Set your exponents equal to each other, and x will be negative 5. All right, and now we are going to kind of go a little bit the other direction. Okay, now I've got them in logarithmic form, and I'm going to put them in exponential form to help me solve this. Okay, so it's in logarithmic form. It's not helping me right now. I will switch this. So I have my base, my exponent, my answer. Okay, and so 2 to the 3rd is 8, and x equals 8. All right. Again, my base is 9, my exponent would be 1/2, equals my answer, which is x. Okay, 9 to the 1/2 is the same as the square root of 9. Technically, the square root of 9 is either positive or negative 3, and I'll talk about this later. You can't have negatives. Yeah, we'll talk about this. But x will be 3 in this case. I'll talk about it in a couple screens, okay? All right, and then here we go. Base is 4, exponent is 3/2, equals x. Okay, now I know that you could plug this into your calculator and do 4 to the 3/2, but I want to remind you of how to deal with these fractional exponents. Remember that this number up here is like this. Okay, so that 3 comes down there, and then the number in the denominator is what is your exponent out here. And we don't usually write the 2's. Square root is assumed to be 2, but that's how it is. Okay, so you can think of this like this. This is like the square root of 4, and the square root of 4 is 2 cubed, and so x will be 8. All right, and one more like this. Again, base, exponent, answer. Okay, so if I want to solve for a now, I have to take the square root, and the square root of 16 comes out to be positive or negative 4. Okay, and there we go. Okay, however, here's the deal. When you're doing this, if I were to switch this to exponential form, I would have this. I would have a squared equals 16. Okay, now I know that it's true that 4 squared is 16, and I know that it's true that negative 4 squared is 16. However, when you're dealing with exponential functions, your base cannot be a negative number. So we're going to talk about this. I'm going to let you leave it right here like this for now, and then I'm going to talk about when things cannot be positive and negative on the next screen. Okay? All right, a couple last ones here. Here we go. These two have the same thing on either side, log base 5 on either side. So since it's log base 5 on either side, I can take this and set it equal to each other. So I will have x plus 7 equal to 2x, and then I just simply want to solve. Okay, so I will subtract x, and x equals 7. Okay, when I plug that in there, I get 7 plus 7 is 14. 2 times 7 is 14. I can take log base 5 of 14, no problem. Okay, same thing here. I have the same thing on both sides, so I can set these two things equal to each other. So 10x equals x plus 81. Subtract x. 9x equals 81. Divide by 9, and x is 9. All right, and one last one where this positive negative business is going to come up, okay? So here we go. I'm taking log base 5 of p squared minus 2, and I can set that equal to p. Now, I need to solve for p here, so I need to get everything on both sides of the equation, okay? Or on the same side of the equation, I mean. So I'm going to make this be p squared minus p minus 2 and set that equal to 0. And then, of course, I need to factor. So I have p and p, and 1 and 2, and negative and positive. Here, p will be negative 1. Here, p will be 2. Okay? And here's the deal. You cannot take the log of a negative number. So this part right here cannot be negative. Okay? This part right here cannot be negative. So here's the problem. When I plug on either side, they can't be negative on either side. So when I plug negative 1 in here, right here, negative 1 squared is 1, minus 2 gives me a negative number. Okay? Same thing here. If I plug in negative 1 right there, that's not going to work. If I plug in 2, 2 squared is 4, minus 2 is 2, and that's okay. Okay, so I can plug this in. I cannot plug this in because I cannot take the log of a negative number. Okay, I cannot do it. And here's what I want you to think about. Think about this. If I were taking 2, and it could be any number, whatever base you have right there, it doesn't matter. But 2 to any quantity, whatever, this would be my answer. And here's the deal. 2 to any number right here, it doesn't matter what number it is. 2 to any number is going to be a positive number, okay? It's always going to be positive. 2 to any quantity is going to be positive. It might be a really small quantity, but 2 to any quantity is still going to be a quantity. It can't be 0, and it can't be a quantity less than 0, because 2 to any quantity is always going to be a quantity. Okay? And because of that, and you think about how logs are opposite of exponentials, that is why this part right here cannot be negative. Okay? It cannot be negative. So just think about that. Okay? So 2 is the only answer on this particular one.